Example 30 on page 563. Divide and simplify to the form a plus bi. So we're given the quotient here, and we want to simplify and write the answer as a complex number a plus bi. So quotient 3 plus 5i divided by 4 plus 3i's. When you divide by a complex number, 4 plus 3i, multiply by 1, and this 1 is made up of conjugates of denominator. So 3 plus 5i times 4 plus 3i, I'm going to multiply by a factor of 1, and this factor of 1 is made up of the and the factor of 1 here is in terms of the conjugates of the denominator. This denominator, 4 plus 3i, has conjugates, and this conjugates equal to 4, same a, which is 4, minus opposite side 3i. So opposite side of the imaginary term, or the term with the I. So denominator 4 plus 3i has conjugates 4 minus 3i. So I'm going to multiply by factor of 1 in terms of conjugate of the denominator, which is 4 minus 3i. Okay, so as you see, 4 minus 3i divided by 4 minus 3i is 1. So this is a factor of 1 in terms of the conjugates of the denominator. Then I'm going to multiply numerator with numerator, denominator with denominator. Denominator is 4 plus 3i, 4 minus 3i. Multiply numerators, 3 plus 5i, 4 minus 3i. Okay? Now, for these type of quotient, where you divide by a complex number, by now I hope that no surprise that the goal, we want to do that because we're going to simplify the denominators, which is the product of a complex number and its conjugates. Remember, when you multiply a complex number by its conjugates, the answer is a real number. So that's the reason why we multiply by the conjugate of the denominator, so that we can simplify the denominator to a real number. So if you recall, the formula difference of square is equal to a minus b times a plus b. Okay? So we're given 4 plus 3i times 4 minus 3i, which is similar to the right hand side of this formula, a minus b times a plus b. That means you can simplify the right hand side to these two terms, a squared minus b squared. So I'm going to use this formula to get this left hand side. So applying this formula to the denominator, you get a squared, which is 4, so 4 squared, minus b squared, b in this case 3i, so 3i squared. And now, for numerator, because this is not conjugate of this, or 4 minus 3i is not conjugate of 3 plus 5i, so you cannot use this formula. You cannot. So that means you will use the FOIL method. So take 3, multiply by each terms inside the second factor. 3 times 4 is 12. 3 times negative 3i is negative 9i. 3 times negative 3i is negative 9i. And then take this 5i, multiply by 4, you get positive 5 times 4 is 20i. And then take 5i times the second term, which is negative. Positive 5 times negative 3 is negative 15. And I times I is I squared. Okay, let's verify. 3 times 4 is 12. 3 times negative 3i is negative 9i. 5i times 4 is 20i. positive 20i because both factors here have positive signs. So 5i times negative 3i is negative 15i squared. This denominator 4 squared is 16 minus 3 squared is 9, I squared is I squared. And then simplify the numerator by combining like terms. There's only the constant 12, so to leave as is 12. These two terms both have I, so you can simplify by combining like terms. 20 subtract 9 is positive 11i. Okay, and then there's only one term with the I squared, to leave as negative 15. But now, notice that I squared, we know what I squared is. Using this formula, I squared equal to negative 1. So substitute negative 1 for I squared. Okay. Simplify further, we get for the denominator 16 stay negative 9. Now, again, you know what I squared is, which is negative 1 here. So replace negative 1 here for I squared. So for the numerator, let's see, 12 plus 11i. Negative 15 times negative 1 is positive 15. Okay? And the limit continue from here to here. So you actually can combine 12 and 15 in the numerator to 27. 12 plus 15 is 27. Remaining is plus 11i. And the denominator, 16, negative 9 times negative 1 is positive 9. Okay? And then simplify the denominator, you get 16 plus 9 is 25, 27 plus 11i. Now, you're not done yet because they asked you to simplify the answer to a plus bi, where you have two terms, a real number and imaginary term. What you got here is only one term, one fraction or one quotient. So to split the fraction to two terms, and the middle is the addition, you use this formula. So one fraction you can split into a divided by c plus b divided by c, or you know by now that when you combine these two fractions with the same denominator c, you can rewrite this as a plus b divided by c. Okay, so I'm going to use this formula, which is similar here, one quotient, and split into two fractions. So we have equal 25 plus over 25. So the first one is 27. Second one is 11i. And you're not done yet because usually we want to write a constant, a coefficient in front of the I. For this, they go together with the I because I in the numerator. So split this coefficient here, 11 divided by 25 to I. Split it, we would get 27 divided by 25 plus, rewriting this second term, you get 11 divided by 25 times I. So the answer for example 30 is 27 divided by 25 plus 11 divided by 25 times I. And it is a complex number.